So the title of my talk is How Do I Build a Better Selenium Grid with Docker? And I can't really see much. You guys are all over the place. You should move closer because I'll be doing tap dancing here. And if he forgot, there'll be chainsaws throwing. How many of you guys are using presently Selenium Grid in all your environments? Internally, so we get, well, half the room probably. And how many of you guys are using Docker to build? So Docker, but building Selenium Grid with Docker? One, two. Oh, all right, good. So you'll know what we'll be talking about. So thank you for coming. First, quickly, my name is Marek J. If you see my last name, it's pretty long. It's Polish. Mostly people know me as Ruby Tester. And I work for HomeAway, which is a vacation rentals listing company, and we have over 1 million vacation rentals around the world. So a few months ago, I was in this situation where I needed to manage internal Selenium Grid, and it was built on virtual machines, and it was kind of painful. It was managed by Puppet or Chef. So you guys use Puppet for managing your virtual machines, I hope? You don't do it by hand, right? No? Yes. Puppet, Chef, Salt, all these other things, good. Ansible, yes. Anything that works that helps you provision a machine quickly. The Selenium Grid constantly required, configuration, and whenever we brought out the virtual machine, we needed to tear it down, or we needed to add some new browser came out and all that stuff. And this was a significant portion of our time. And I don't know what your strategy was for Chrome, but I personally didn't have a really good strategy for example, for Chrome. Chrome doesn't release, like, say, this is a version 39, this is version 41. It's just you wake up one day and then you have, Chrome 45 now on your machine, and unless you don't upgrade it. So around that time, that was a few months ago, I found this really great project. It is on GitHub. It is part of Selenium HQ GitHub organization, and it's called Docker Selenium. And how many of you have heard about this? Some of you did. Okay, I'm here to announce, yes, it is there, it's available. It's an open source project. What's so great about it is that it defines the complete Selenium Grid stack as Docker images. So the entire idea of defining and building a virtual machine goes away because it is already defined in Docker images. This is the part that defines it. What do I mean by this entire stack? And this is something that you probably go through a lot, right? So you need Java, Selenium, jar, browsers, Firefox. Optionally, you want to have VNC for debugging so you can see the browsers running. Even if it's headless, you still want to have some visual confirmation. So all this earlier stuff kind of went away when we decided to take a look at images. So these images really became valuable for us because we didn't really have to do all that provisioning and dressing up of virtual machines. This is interesting because this is a definition, what I mean by that, but where are the images? Before we go that, I just want to give you a glimpse of something. What defines images is a Docker file, and then we can go over that at some point. By the way, I will skip a few things. I will touch upon some concepts, and I will be here throughout the day and then tomorrow. If you have any questions to make sure that you understand this, I'll be available. I'll be happy to set up small sessions, and we can do all this Docker stuff together on your machines. So an example of this one is this one builds a hub, and this one is available on Docker Selenium. We hooked up a Docker Selenium project to the Docker Hub so that when a Docker file gets pushed to GitHub, we automatically build images. The images are automatically built and available for you to download from. Actually, we're going to go over that part. What does it mean to download an image? This is at hub.docker.com. There's a user called Selenium. All these images are available. There are 11 of them right there. And the ones that we really will care about is a standalone image, and for building a Selenium Grid, there'll be a hub and a Node Chrome and a Node Firefox. So this really revolutionized our way of thinking about building a Selenium Grid, because we didn't have to do this whole configuration management, and we didn't have to sink a lot of time into provisioning machines. What makes it run is that if you have a VM that can run a Docker image as a container, you're good to go. You really don't need to worry about how well that machine is provisioned, as long as it has a Docker machine installed on it. And in the last couple months, we actually have Selenium Grid at HomeAway running. We actually have several Selenium Grids running on our internal cloud. We've made it self-service so that teams who need Selenium Grid basically go to a place and say, I need one. And they spin a machine that runs a hub, and then they spin 10 or 20 nodes, and then that's running for them. If they have a parallel tests and they need to run 40 browsers or 80 browsers at the same time, they run it. If they don't need the grid, they just shut it down. Currently, we're running, I think, 3 kind of static grids for people to try and for teams to get started. And if some team has very specific needs, then they will just pick their own. So this is more of a talk, an explanation, as well as a case study to show you how we're doing this, and a demo of how we can do this. I think there was a Selenium Grid yesterday, right? There was a Selenium Grid workshop. How many of you guys attended to the workshop? Right, so half of you or so. It was kind of, I'm sure, I was a little bit there to see what the issues that people had with, like, how do I get this going? I need to download stuff, and So in the next 30 minutes, pretty much, we're going to go over the stuff and the demo, and I'll show you how we can run a Selenium Grid on a local machine, and then we're going to set up one in the cloud, and I'll use DigitalOcean cloud provider as an example that we can just talk to from a regular machine. So I wasn't sure how the internet was going to be, and I didn't want to go into this live mode thing and get stuck, and I didn't want you to suffer, like, what the hell is he doing? He's doing, and I pre-recorded some of these, but they'll look like they're real. So the main thing is, after we do this demo, I want to, I'll be happy to replicate this thing that I'm doing on this machine to show you how you can do this on your machine so you can have something valuable for you to take back to your teams wherever you work. And okay, let's get started. All right, well, first of all, before we get started, I would like to acknowledge the contributions of these 2 people. That's Leo and Matt, who actually put this project on the map. And I just want to let you know that contributing to open source is a really great thing, and I hope you are contributing. By being here, you are, just by your presence. So thank you very much to all the contributors, and hope that more of you will come and join us to do something on Selenium. All right. This is a simple README that you see in our Docker Selenium. It defines 11 images. So we're going to use 2 of them. Well, actually, in this demo, 1. But we have something what's called a Selenium Standalone Chrome Debug or Firefox Debug, which is a standalone Selenium jar that runs with VNC. So when you run tests, you can look into it. What's great about it is that when you are developing your tests, you can run this as a service on your local machine to give you the browser session, and then you run your tests internally into this Docker Selenium image. When it runs on the grid, it will run in the same way in the same environment. So that cuts down all this configuration management on your local machine, like what browser do you have installed? Do you have this version of Java or not? If you're running Chrome, oh, I need a Chrome driver as well. So when you're using an image, all of it is packaged for you. And when you spin it, you just run it on the machine. So all this thing like, oh, works on my machine, oh, it doesn't work on my machine, that kind of goes away. So if you run it on your machine, if you go to somebody else and you pair program with someone, And they have exact same Docker image. You just run the same exact test in the same environment, which gives you this promise that Docker has, where we run the environments are the same. All right, here's a quick thing. So for this Selenium conf, let's take a look. You guys, I hope it's big enough that you can see this. So the first thing we'll do is Docker run. We're going to run, and we'll go over these commands. I'm going to run a name Selenium Docker container. And what we're going to do is publish port 5900 for our VNC viewer so we can connect to it and see it. And this is a continuation character, and we need a port 4444 to expose and publish it to the host so that we can run the Selenium Grid standalone. And we're going to run a Selenium Firefox debug. Right. Okay, so I'm just typing here. All right. And boom, done. That's it. The Selenium is running. The Docker PS tells me that I have one process running. It took me about a second to bring up a Docker container. And it runs as a process. So let's open a VNC here. And we can see some, in a second, just a 10-second test running. So you can see this kind of makes it real for you. All right, there's a VNC, putting it in, moving it in place. I'll pretend that I'm busy typing here. Oh, yeah, this is good. Yes. Is this okay, big enough for everyone, I hope? Yeah. We run a simple test when bundle RSpec. Here's a browser coming in VNC. We just go to homeway.com, search for a vacation rental in Austin. If you're ever in Austin, please stop by. And we look for some dates. And on the left, you'll see some logs spitting out what's going on with the test. And we're done with the test. Okay, we'll come back. Boom, got it. Just to see, the Docker now it's been running, and now I can stop it and actually throw it away if I don't want it. What just happened there is I brought up a Docker Selenium, which was the entire environment to run a test in. It came up in about a second. And I was able to run tests immediately. And I can now stop the Selenium container and actually throw it away. This is the idea of immutable infrastructure. The lovely part about this is I don't really have to worry about running the same exact container that may have created some data in there, and you have some tests that create data. I don't really need it anymore. I can just throw it away, and I can start a whole brand new container. Was that? Okay, I thought somebody was asking me. All right, so this is for you guys to try later on. This is how you run a Docker run standalone. You can just copy and paste it into your command line and run it on your local machine, poke around, see a VNC. Well, let's jump in quickly to what is Docker and what is this all about. I was thinking about how do I explain this. The best resource really is docker.com. There's so much information on getting started and what it is and what it's about, and so everything you really need to know. But one thing caught my attention, which is their slogan was build, ship, and run. And I thought, okay, this is a really good conceptual framework and a way of thinking and modeling, really what's going on with Docker. And so let's kind of examine the idea of build, ship, and run. So the idea of build, what's really happening with Docker is it takes all of the application dependencies, everything that you need, and basically packages them in an image that is runnable. There is anything that is a dependency should be in that particular container. So there's no need for you to go and say, oh, I'm going to run something on a machine, and then you checking a VM, do I have the right version of Java? Or is my class path set up correctly? Or is it the right version of Java coming up? This allows you to build very small images that are purposefully built for that service and that service alone. You don't have to, you don't have to put anything in this image. And you define it and you build it, and there's a resultant image that you can then store and ship around. So we use Dockerfile for instructions, and we'll go over that. The ship part is, how are these images shipped? There's an idea of a registry that Docker has, and I showed you earlier where we keep our Selenium images, which is in a Docker Hub registry. This is a public registry that you can actually set up your own account on. If you want to build an image, you can push it there and have this image and share it with somebody else, with your team. That's also available. It's open source and it's free. And this is how we can do this. So the idea is we have this image, and then we basically decide, okay, I can ship it to the registry, and then I can go to another machine that has Docker running on it, and I can pull this image down onto that machine and then run it. Or if I don't like this machine or something happened, I can just delete the machine, go to another machine, pull the Docker image, and then run it. So the idea of like provisioning a machine kind of goes away, because the provisioning is really just pulling an image that is already built for you. And that's kind of the time. Another part that you will see in Docker is that an image is really a repository of layers. If you guys are using GitHub, which I think pretty much everybody should, right? I don't know. Yes? I'm not going to ask. But if you're using GitHub, that's the idea of each commit is a layer. Each commit on a tree is a layer pointing to the commit before it. And Docker has the same idea, is that the image is really a repository of layers. As you were building an image, there's something that was there in the beginning, then you add something else, then you add something else, then you add something else. If a new image is pushed to a repository and you have an earlier image on your machine, when you pull to your machine again, the same image, you do not pull the entire image. You just pull the missing layers. So this creates this efficiency in the system where you're constantly not pulling and pushing all these 500 megabyte containers. You may already have part of it, and you might need just the later one. So building and rebuilding images and pushing them around becomes just dealing with the latest layers of the image. So we'll see that in action as well. And then the last part is the run. So, when we say run, what do we actually run? So I stole this piece from docker.com. It says, Docker loads your image and runs it as a process on your host machine, right? There's no boot time like virtual machines, because Docker containers wrap a piece of software in a complete file system that contains everything it needs to run. And that is a bit cerebral, but you basically load your image, or Docker loads your image, creates a container for it as an environment in which your image runs, and the container runs as a process on a host machine. There's no booting, there's no process ID 1. There's just some process that runs. From the host machine, your container looks like any other process that runs on this machine. You can kill the process, you can remove it, you can start a new process. You basically deal with it as processes. So if that goes over your head a little bit, it did on mine in the beginning, it just made sense at some point, like, oh yeah, that makes sense. And finally, you will see this slide probably about Docker. And how many of you guys looked at this slide and wondered, what do they mean? Has anybody really examined, or is it just pretty pictures? Yes, some you do. So we were in a world of virtual machines where, let's say I have an infrastructure. And by the way, these slides are directly on Docker, so you can go over that. But spending a few minutes examining this would be good. So on the left side, we have virtual machine. This is kind of how we know the world. On the infrastructure, you have a bare metal, you have something in the cloud, or your laptop, and I'm going to use the laptop. Let's say I have a laptop machine, maybe some kind of a Debian or Linux, Ubuntu, Mint machine. I have my operating system on top. Then I need a hypervisor. So maybe a VirtualBox, which is available, maybe KVM or something. And the hypervisor allows you to build virtual machines on top of it. What's great, I mean, this is kind of a great world, but it's actually a separate machine that's running on a hypervisor. So when you're entering this machine, it's a complete new machine. There's a boot process. There's a whole operating system there that you boot. And then finally, you have to provision that machine with what you need. So all your libraries, your binaries, and then finally, your app sits on top of it. So every time you build it, you need to provision that machine. On the Docker side, what we have, again, I have a laptop that has maybe and I'm going to use the Linux part here, and it has a Docker engine. And the Docker engine is unlike the hypervisor because it doesn't build virtual machines on top of it. The Docker engine is a service running on the operating system that allows you to create those containers and put images in there and then just run them as processes. This makes it really fast and efficient. The entire VM provisioning goes away. You may have seen this kind of a picture of Docker. It's a good conceptual way of looking at Docker. The ship is really the host. This is the machine that is capable of running containers. It really doesn't matter what ship you use as long as it has these specifications for saying, yes, I can load containers on it. And many people use this kind of a glorified way of looking at containers like, hey, how many containers can we load on this ship? And this is what happens. Now, what are we talking about in terms of Selenium? We just need a ship that stores one container. And that's really the gist of this whole thing. It's not about wildly loading all of these containers and saying, hey, how many containers can I just maximize on this ship? Because you're not maximizing, we don't really care about maximizing the capacity of a ship. What we want is agility. We want something that we can put on the ship, run it, move it around. If it works, great. If it doesn't, throw it away, put another one on. That's really it, and this is the idea for a Selenium Grid. So I just, whenever you see a picture of the ship with 50,000 containers, you may want to just, look at it and say, hey, we really only need one. But we want it to be contained. We don't want to dress the ship. We don't want to provision this ship. We just want to give it an image, and we want this ship to just run this image, and that's it. All right, so we did the standalone grid. Now it's time to build a Selenium grid. In this case, we're going to use 3 containers on a local machine. So I'm hoping that my machine is not going to keel over with just 3 containers. This would be the Hub, the Chrome node, and the Firefox. So let's set this up. Just pointing to you on our Readme page, this is what we have. In this case, I will try to show you when I do something like Docker pull Selenium Hub. And this is really what's happening here. I'm pulling all the layers of the image. You can see some of them already exist, some of them I'm downloading, some of them have completed, and the pull is complete. Next one is Docker pull Selenium node Chrome, and I'll lie here that I already have all the images set up, but I just want you to see this is really, as we go through this process, this is what happens. Each one of these IDs is a layer ID for this image, just like GitHub commits. And so after we do this, we want to run Selenium Hub, and so we are running Hub. We're going to give it a name, Hub. And we're going to publish all the ports. So we know port 4444, it matters. But in this case, we'll just let Docker decide what port. Docker logs Hub shows me, OK, Selenium Grid up and running. Here's the process, container ID showing you. And it says 32770 port is pointing over to 444. Let's open a browser. Here's a Hub. That is kind of useless, so we need a node. So let's go run a node. And since I'm on the same machine, I'm going to link it to the Hub. The internal networking is going to handle registration and running it. As you can see, again, running it, the container ID shows up. The whole node just came up really quick. Here's the second container running. And I think we're going to look at the logs for this container named Chrome. You can see, yep, Chrome is up and running. We're going to add a node Firefox to the hub. That's a third process ID. So this is 3 containers running on a machine. And I think looking at logs for the Firefox, same thing, it's up and running. Docker PS, I think we're going to do here Docker PS, yep. No, Docker logs, hub. So the last 2 lines now shows you, okay, we registered both nodes to the container, and here they are. We're running a local Selenium Grid from containers. So just for fun, we're going to run a quick test, but just using command line. In this case, Ruby. There's a Water WebDriver bindings for Selenium. You guys, who's using Ruby? Just curious. Ruby. Yes. Oh, I forgot. I am Ruby tester on Twitter. So just in case. So here we're starting a browser. We're doing a remote browser, and the URL I'm giving it is the Docker machine URL with the port 32770, which then publishes to port 4444. Here we have a browser, and we're going to go to where? We're going to go to the Selenium Conf website, and we're going to output a title just to tell you this is not made up. All right. So this is the grid that's running on a local machine. Now, of course, you will not be running Selenium Grid on your local machine. I hope not. That would be a bit of an overkill. Oh, and here's what I'm showing you. The browser goes away. So in this case, what just happened, these are kind of breadcrumbs for you to try this out on your local laptop. We're pulling all these 3 images from the Docker Hub. This is what's happening with the Docker layers. The green arrow says, yes, I already have these. The orange one is, yes, I'm in the process of downloading that. The blue is like, yeah, I've pulled them. I have the image definition. I just need to, download them. And then we run the following commands. So you can also copy and paste them into thing. One thing to watch out, some people may not know, is the backslash in Bash is a continuation characters. It's not part of the command. So many times I give these examples and people just copy and paste, and there's a backspace and they said it doesn't do anything. Yeah, it doesn't. So if you do copy and paste it doesn't work, just remove the backslash. So this is the idea of, when the containers are running, you can see this by outputting Docker PS, which is processes. What are the processes currently running on the machine? And it usually gives you a container ID, what is the image that's currently being executed, and there's some more information about that. So that really is the demo of the standalone for your test development. This is kind of a proof of concept that you can build the Selenium Grid on a local machine. But of course we don't. What we want to do is probably run a hub on a separate VM, and then each node on a separate VM. And we want to bring as many VMs as we want and have those VMs connect to the hub. In the case of showing it on a local environment, it was easy enough for us to just say, well, link this image to the hub. But when you have them running separately and they don't know about each other, you actually need to provide the node with the host URL of the hub and the port. So I'll show you this. All right, so this is kind of what we do at HomeAway. We have made this small thing called Hagrid, after Docker, if you've ever seen that. And Hagrid is our HomeAway grid. And the name became kind of funny because it was easy for everybody to know, okay, this is what we're doing. Our Hagrid runs a hub on a small VM. It's a 2 CPU machine with, I think, 6 gigs of RAM, and we run a hub. So again, small ship, 1 container, runs a hub. If something ever goes wrong, we throw away the entire VM, we bring up another VM, we pull an image, we run a hub. We just change DNS entries to maybe a CNAME to another machine. That becomes very simple, lightweight. There's really very little provisioning to the base VM. It just needs to come up. And we use VMware, and we just self-service. If you guys use vRealize, you know, you can build blueprints and just click the button and it brings up a machine. So now this is the entire puppet that is needed to dress these machines with Docker images. So before we had reams of stuff. I don't know how much of a puppet you guys do. And I see people take photos if you want. The whole image is already uploaded, and I'll show you where it is. But that's really it. It's just a few lines of code. We're using a Puppet module called Docker, and we just say, go Docker run. This is the image, and you can see the $ Hagrid Hub image, which is a fact that we basically put on the server. So in Puppet, there are things like facts that you can put on the server. And we run it with these kind of grid timeouts that work for us, and we give it 3 gigs of RAM on this machine, and we publish port 4444 to this. And if we need to run a different image, we just go to this machine or go to another machine, and we switch the fact. We just say, oh, run this hub now. What we do is when we use the publicly available images for Hub and we save them locally and we put them in our registry, and we'll say, okay, this is from this day, or this is for this version. And we just freeze them so that we can have them on our registry. When new code comes in, we examine it, we run some tests on it, we take it down, we freeze it, the image, and we just have it running. And then at some point, when we want to switch to the new one, we use the new one and we throw away the old one. This is the entire code currently needed to run a node. So again, the image is either a Chrome or a Firefox. There are 3 pieces, well actually 2 pieces, no, sorry. Yes, there are 3 pieces of configuration. What we need is we need to tell the hub, hey, I am the node and my remote host URL is this fully qualified domain name. And please talk to me on port 5555, which is where we publish the ports. And we also need to tell the node, by the way, the hub address is this, and the port is this, which is usually 4444. Additionally, we have, you guys run browser mob proxy by any chance? Yeah, anybody? Yes, yes, a couple people. If you run browser mob proxy, we also containerize browser mob proxy, and that's actually that's available publicly too. So we have another machine that we just bring up. You know, there's no need to like, oh, what else can we fit on this virtual machine? We run the hub, the node, and the proxy. We're like, no, no, no. Just bring a very small VM, put a proxy on it as a microservice, and just run it. If something happens, we'll just throw it away. We'll bring another one. The idea is to have immutable infrastructure. Basically, use it up, have it be solid. At the first sign of trouble, something's not right, people say, oh, I can't SSH to this machine, something happened, throw it away, get another one. There's really no need to investigate what happened. Well, sometimes we do. All right. So, whoopee. The next thing, the next quick demo, no videos, is how would you replicate such a thing on publicly available, on clouds? So I chose a DigitalOcean. You guys are familiar with DigitalOcean? Yes, some? Okay, you guys are familiar with AWS? Yes, everybody's familiar. Okay, well just think of DigitalOcean as like this other thing that you can run. It's not as maybe robust, but it's there, it's available. You can spin machines in DigitalOcean in the cloud really easily. So in this example, I'll start 2 machines. One is, I'm just going to call it Ocean 1 for hub, and then Ocean 2 for the host. Before I do, I didn't say much about how to run a toolkit on your local machine. So if you go to docker.com and go through a couple pages of getting started, it tells you, please download this Docker Toolbox. And part of it is a Docker machine, which is a, well, it says here, on your computer, it configures your Docker client to talk to the machines, and you can talk to the cloud providers. And one of them is DigitalOcean, and I think AWS is one of them as well. And this machine from your local machine, you can connect to the cloud and create VMs and then just tell them to run some Docker images. This is kind of what happens here. So usually DigitalOcean calls their VMs droplets. These are very small, tiny droplets. These IPs are real. The first one runs a hub, and I think if you want to hit it right now, there's a hub running on this thing, because they just, before the presentation, started a Selenium Grid on this. This is what you would run on your local laptop to create a machine. So you say Docker machine, create a VM that's capable of running Docker images. The driver for this is going to be DigitalOcean. Plump in your token in there, give it a name, there it is, Ocean 1, give it a name, Ocean 2. On my laptop, when I say Docker machine ls for listing, it says, hey, I have 3 machines running. So in an earlier 2 demos that I was telling you, I was actually running a VirtualBox on my Mac, because Mac cannot natively run Docker engine. So, boo. And you may have these kind of problems. So if you're on a Linux machine, you'll have much easier, but everybody's running on a Mac. So yes, I'm sorry, you're going to have to deal with VirtualBox. The little asterisk there in the active, it says, yes, I'm talking now to the Ocean tool. I can switch environments from my command line and say, oh, when I run Docker, actually run Docker on that machine. And we're going to start a hub. This case, it's kind of a similar way like we did on a local laptop. We just say Docker run, -d means daemon detached mode. We're going to give it a name hub. We're going to publish port 4444. Here's the URL. Somebody wanting to go there? Yes? Anybody gone there yet? No? Okay. It should be running. We'll check. This is how you start the hub. This is how we're going to start the node Firefox. And what I showed you in Puppet, it's really the same thing that you would do on the command line. You just say Docker run, we're going to give it a name Firefox, publish the ports 5555. I need to tell the hub, this is my IP for the remote host, and I need to tell the node, where's the hub? And that's it. That's the whole configuration. On the second one, we're going to run a Chrome node on Ocean, and that's it, the same thing. Since port 5555 was taken by Firefox over here, see that when the Docker container comes up, it says, I am listening on port 5555 inside the container. So in the host, I need to say, oh, I've already used 5555 to talk to 5555. So now I'm going to use 5556 to talk to this. You see how that works? It's kind of a thing. And there were some recently problems with shared memory, so I'm going to mount some volumes from a host on dev for SHM. And this is the hub that's running currently on the DigitalOcean. And we are at 37 minutes, so sorry, I'm a few minutes over. And just want to say thank you. And do you have any questions, any ideas, any battles, or tap dancing, doing throwing flames and stuff? Yes?
So Docker has this idea that each container should essentially, each process should be one thing.
Yes.
And it's actually shown in this slide here that if you use the Selenium Grid outside of Docker, you just set it up yourself.
Mm-hmm.
With the jars and everything. I think by default it brings up like 5 Chrome nodes and 5 Firefox nodes, something like that.
Yes.
It does multiple nodes. And I've noticed the preferred approach with Docker seems to be for each node that you bring up, like in your example, let's have one Firefox node or session available and one available with Chrome.
Yeah.
And it's not advised to have multiple essentially sessions running so that I can say run 3 Firefox tests.
Yes, yes.
Can you sort of talk about that? I think that's part of sort of the Docker philosophy. I don't quite
Yeah.
understand why that is.
Well, it's interesting. So, so I'm not sure if you guys like the idea. I don't know how to repeat your question. So the question was, hey, there's only like one Firefox. How come you don't run like 27 Firefoxes here? That's pretty much it, right? I mean, you have a VM. Come on, how many containers can I stick on this thing? And I showed you a little bit like what happens. So, when you ship containers on a big ship, you're like, well, I have this one big ship that's going to go from here to there. And I have to maximize for shipment, because then, it's expensive. In this case, we're like, hey, VMs are cheap. You just bring them up, run a container, run your tests. You don't need it, kill it, right? So the idea of these images is, I want something to provide me a browser session now, and when I'm done, I don't care what happens to the browser session. And I think what people have done, and this is what we've done before, is bring up the grid and have it running, maximized. We need 40 browser sessions available at any time because someone might need to run tests. And we're like, no, well, you need to run tests. Go bring yourself up 40 VMs, run your tests. When you're done, kill them. I mean, that's kind of like, it took me a while, like, oh yeah. So in the beginning, when we ran this, we brought up a VM and we said, let's run 4 Docker containers on this thing, right? We're going to run 2 Firefoxes, and each Firefox is going to have 4 browser versions of this, and we're going to run a Chrome, and that way on one VM, we'll have like 16 browser sessions. This is great. And then when we started running tests and look at CPU usage, right, it was just like 127% CPU usage, and the tests, when and they would kill containers, or the hub would just go like, I don't know what's going on, kill it, and the nodes would just go down. Also, what happened is our tests would run slower. We could actually see significantly tests running on a VM that had 1 or 2 browsers were faster. They were like 12, 15 minutes to run the entire suite, versus like 40 minutes if the whole load was overloaded. And the idea was, before, you would optimize for, well, if I've spent so much time provisioning this machine, I better have Java 6, Java 7, Java 8, I'll have Chrome 39, 42, whatever on this thing. I'll just have everything on this VM, because it takes so much time to bring it up and provision it, right? Like brand new, I don't know how long somebody's going to talk about AWS, but when I was doing stuff, even in Vagrant, in my local environment, like, okay, you provision it. Okay, I'm going to go get a cup of coffee, come back, and see, oh, it's done. Yeah, 7 minutes later. And today, we're like, no, we don't have 7 minutes. So we don't need to optimize for stuffing as much stuff inside of something, because we have such a long process to have it running. Now we just need a VM. We need a VM that is capable of running Docker images. How fast can I bring this VM up? And with the minimal provisioning, like I just need this machine with, that's it. You just bring it up. If it takes me, I don't know, Puppet runs on this, provisions it, maybe a minute or so, maybe 2. Or I might just create 40 images and then just power them off and have them ready. Because powering them on takes me faster than just like provisioning new ones. So I would bring them up, and they're there, and I would just, and when they come up, the services, with Puppet I showed you the Docker Run Puppet module. It actually turns it into like a systemd service. So when the machine boots up, it runs the service, and it brings up the node, and the node's running automatically. If something goes wrong, we can either SSH to the node, but we're now looking at like, well, where is the bottleneck? Where is the waste of time that we don't need to waste on it? So I'm not sure if that answers your question. Okay, thank you. Yeah. I got 42 minutes. Anybody? Tough questions? No, I don't know. Yes? I can't really see their like lights. Yes, please.
Internet Explorer and running Internet Explorer drivers?
Yes.
Reasonable with like wine or something?
I have not gone into that. I think if you really have to and you need to currently for this we're using Sauce Labs. Like, okay, this is right now too expensive for us to build it ourselves. And Sauce Labs has VMs and that they manage. We'll just point to Sauce Labs and run it there. If it matters for us to see, is there a difference? But if we're testing for functionality and behavior, and I think somebody asked me the question, like I said, well, if IE displays the button in blue and Chrome in green, it'd be like, why are you building a blue button on IE, right? It's like, they should be the same. There might be some edge cases that if you really care about those, Sauce Lab's great for that. Or just use the regular VM on the local machine. And the modern.ie gives you the VMs that you can download and you can run the Internet Explorer. So yeah, it takes a bit of time for that. Any other questions, contentions, fights? So, oh yeah, sorry about that. I swear I can't see.
Do you have any examples of running Docker and Selenium at scale? It sounds like what this approach at least seems to be is that you're not time prohibitive, it's more cost prohibitive. So you're setting up one VM, one hub, is this a per test thing that you're spinning?
Oh, no. So we have three, so when you say at scale, I was curious as how many, what kind of scale were you thinking?
We usually run about 300-ish, 300 to 400 concurrent browsers when we do our testing. So
Okay, yeah.
the rest are 12-hour, 10,000 Selenium tests. We did 22 to 45 minutes.
Yeah, so what we've done is we have multiple Selenium grids. Instead of overloading one hub and adding as many nodes to it, we have teams that run their test suites, and they'll say, okay, you guys spin your own hub, and let's say you need 80 browser sessions. And when you run all in parallel, this is your grid. Nobody's touching it. It's all for your own usage. Because we can bring them up as self-service really easy. And then some other team goes, okay, we'll bring our own. So these are short-lived Selenium grids. And we have 3 Selenium grids that are always on, all the time running. So that anybody at any time, if it needs to run tests, we have Selenium grids running for them. But if a team says, hey, we have a release and we need to run, let's say 120 browser sessions right now in the next 25 minutes, they usually have a grid that is there available for them.
So think of it in the terms of continuous delivery. Like you don't have a team, you have a build pipeline.
Yeah. Yes.
Is it something you're spinning up on in that kind of sense?
Not yet. Not in that kind of sense. It's usually teams will know that there's some kind of a build going. But for continuous, we have these 3 grids. And the grid has, I must say, 24 nodes. So we got 48 browser sessions. We actually found out that if we run, no, in this case it's 1. But we run a node with 2 browser sessions, and that gives us about 80% CPU utilization, and the tests run faster. So that way we can do that. Right? That's it? Anybody? All right. Well, thank you for your time.